Welcome back to Mive Explained. Today, NFT sniping, mint sniping, and listing sniping, and the quietly brutal rule underneath both. The winner isn't who clicks first, it's whose transaction the block orders first, and that order is bought with gas. We'll build a scarce mint, watch a bot beat a human who submitted earlier, and then run it live on a local chain so you can see the block get sorted by gas right in front of you. Let's go. First, the idea. When a hyped NFT opens a public mint or someone lists an item too cheap, the transaction sits in the public mempool, the waiting room every pending transaction passes through, and anyone can watch it. Now, the crucial part, the block builder doesn't order transactions by who arrived first. It orders them by priority gas, the tip you pay, highest first, because that's what pays the builder. So the person who gets the scarce token is simply whoever paid the most gas, regardless of who clicked first. A bot watching the mempool sees your mint, copies it, attaches a bigger tip, and gets placed ahead of you in the very same block. You were first in line, and it cut in front by paying more. Let's build the scarce mint. Here it grabs the whole race in one picture. On the left, the mempool. The user sends their mint first, but with a normal cheap gas price, 1 Guai. A moment later, a sniper bot sends the same mint but with a fat tip, 5 Guai. Both are now pending and the order between them is still undecided. Then the builder assembles the block on the right and sorts by highest gas first. 5 Guai beats 1 Guai, so the sniper is placed at position 0 and the user at position 1. Position 0 runs first, mints the one rare token and gets it. Position 1 runs second, finds nothing left and reverts, sold out. Same 2 transactions. The user even sent theirs first, but the bot paid more gas and was ordered ahead. You don't outbid on price here, you outbid on gas. Let's prove it in code. We build it in Foundry. Here is a scarce NFT rare mint. There's a maximum supply of exactly 1, a running total, a record of who owns each token, and the standard transfer event. The mint function is the whole game, so let's fill it in. Here's mint, first line, the guard. Required total supply is below the max, otherwise revert with sold out. Since the max is 1, exactly 1 caller can ever succeed, the very first one to run in the block. Then we hand out the token, record the caller as its owner, and emit the transfer event. Notice there's nothing unfair in this code, no allow list, no bug. It's plain first come first served. And that's exactly the problem. Because first to run isn't first to click, it's first in the block's gas order. Let's watch the race. Here is the test. A forged test runs the calls in the order we write them, which is exactly like a block whose order is already decided. So we make the order the variable. First the sniper mints, standing in for being ordered first in the block, then the user mints, ordered second. We check who ends up owning the token and what happens to the one who came second. Run it. The sniper ordered first mints token 0, and the owner of token 0 is the sniper. Then the user's mint runs and it reverts, sold out, there is nothing left. The sniper won the 1 token purely by being placed first. In the test we set that order by hand, so now let's see what actually sets it on a real chain. Gas, live. Here it is live on a local Anvil chain, and every command is reproducible. We deploy the scarce NFT, then turn off auto mining so transactions queue in the mempool instead of settling instantly. Now the user sends their mint first at 1 Guai, and the sniper sends theirs after at 5 Guai. The pool shows 2 pending. Then we mine 1 block and Anvil orders it by priority fee, highest first. Look at block 2. Position 0 is the sniper at 5 Guai. Position 1 is the user at 1 Guai. The user submitted first, but 5 beats 1. So the sniper is placed ahead. And the result, read straight off the chain, the owner of token 0 is the sniper, its transaction succeeded, and the user's transaction failed. Mint reverted, sold out. The bot paid more gas, landed first, and took the token. On a real chain you can rerun yourself. So why does this keep happening, and how do you stop it? It happens because 2 things combine. The mempool is public, so bots see every pending mint, and blocks are ordered by gas, so bots can always pay to be placed first. A naive first come first served mint is really a gas auction in disguise, and the same move snipes a mispriced listing, outbid on gas, and buy it out from under the seller before anyone else. The real defenses fall in two camps. One, hide the transaction, route it through a private mempool like flashbots protect so a sniper can't see it coming. 2. Don't design it as a raw race at all. Use a commit reveal, an allow list, or a batch auction with a uniform price. So being first by gas simply doesn't win. Fair ordering has to be designed in, it isn't free. Quick recap. A block is ordered by priority gas, not by who submitted first. So for anything scarce and first come, the hyped mint or a mispriced listing, a bot watching the public mempool just attaches a bigger tip and gets ordered ahead of you taking the token, even though you clicked first. We proved it two ways. A test where the one ordered first wins and the other gets sold out, and a live local block where the 5 Giragui sniper lands at position 0. The fixes are private order flow, so the bot can't see you, or a fairer design like commit reveal or a batch auction so raw gas doesn't decide the winner. A quick note, rebuilding these MEV plays safely and explaining them line by line takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next breakdown. Thank you. And that's NFT sniping, mint and listing, told in full, why the block's gas ordering means first to click isn't first to win, shown in a test and live on a real chain, plus the defenses that actually work. Next episode, another MIVE play, rebuilt from scratch and explained. Subscribe so you don't miss it, tell me in the comments which one to break down next, and I'll see you there.